Alright, moving on to problem 3 and 4. We're supposed to solve the system again using both graphing and substitution. I'm going to do the substitution on this side and then graphing on a later slide. The honors one I'm going to do after this video, or these non-honors videos, the regular videos, and then later I'll add in the elimination part. Anyway, so I'm going to use substitution on this side. To use substitution, you have to solve one of your variables, one of your equations for one of the variables. This one looks easiest to solve because all you have to do is like add y to both sides. And so I'm going to do that. I'm going to add y to both sides of this equation. The y's disappear on the left, and now we have x equals 11 plus y. Okay, now we have one of the equations solved for x. So we can take this right side and plug it in for the x in the other equation. And whenever you do that, remember you put it in parentheses. So wherever this x was is now this parentheses stuff. The plus y is still there and equals 19. Now we need to solve for y. Distribute the 2 through to get 22 plus 2y, and then you got plus y there equals 19. I'm going to combine my y's, and while I'm at it, I'm going to subtract 22 because I'm trying to save some space. I'm running out really quickly. 2y plus y equals 3y, and 19 minus 22 gives me negative 3. I divide by the 3 to get y equals negative 1. Okay, so that's half of my solution. I'm going to take that, I'm going to plug it back into this y here, this y that got slightly drawn over, to notice that x equals 11 plus negative 1, which means x has to equal 10. Ta-da! And if you want to combine those into a point, whoops, that's not 12, you can write out the x-coordinate, comma, y-coordinate, and ta-da, that is the solution to this system of equations. Notice how the solution method is kind of easier than graphing, but we do the graphing one because you're going to run into a lot of graphs in your future, and so we're just kind of getting used to them right now. The graphing portion I'm going to put on here in just a second. Okay, before we can graph it, it's ideal for us to solve both of these equations for y. So I'm going to take the top one, I'm going to solve it for y. That means I have to get y all by itself on one side. So I'm going to subtract the x, to get negative y equals 11 minus x. And I'm going to divide by that negative 1. And remember, when you divide, you have to divide every item. So 11 divided by negative 1 is negative 11. And negative x divided by negative 1 is positive x. So that one got solved. I'm going to solve this right one. And all I have to do to solve for y on that is subtract both sides by 2x, because there's nothing with the y. So now I got y equals 19 minus 2x. So I finally got my two equations. I'm going to take both of them and graph them on the next slide on this coordinate plane. I'm going to copy them over real quick though. Okay, so I copied my equations over. Something to notice, my y-intercepts are really big. And like they're not even going to fit on this graph because it's too short. And so what I can do is either A, choose my graph, or I can change how I'm going to graph it. I think what I'm going to have to do in this case is actually just get rid of these numbers and I have to put new ones down. So I'm going to do that real quick. Okay, so for my graph, I changed my tick marks so each one counts as 3. And so now it's like big enough to fit these y-intercepts, the negative 11 and the 19. So I'm going to first graph my left one. I'm going to use red because I'm already on that. My y-intercept's negative 11, which is going to be here-ish. And I have a slope of 1, so I go up 1, right 1, up 1, right 1, up 1, right 1. So I'm going to go up 1, right 1, give me a dot there, up 1, right 1, dot there. And I got a few dots that lets me know which way my graph is going, which is that way. And I'm going to switch colors to graph my other one, with this one on the side. My y-intercept is 19, which is a little bit above 18, so I'm going to put it right there. And I have a slope of negative 2x, that's negative 2 over 1. So to get this slope right, I'm going to go down 2, right 1, down 2, right 1. So I'm going to go down 2, right 1, give me a point there, down 2, right 1, point there, and you really only need 2, but I put 3 just to kind of give me a better shot at trying to graph this correctly. And that's how it goes. And my intersection point is right there, which is like 11 or 10, negative 1-ish. And that's actually pretty darn close to our actual solution we got, which was 10, negative 1. So once again, graphing is a guessing game, trying to figure out where the solution is. Sometimes it's really clear, sometimes it's not. Just depends on how well you graph. If you're doing it on the computer though, or like you have a graphing calculator, it can be a lot easier to deal with.